You ever get that feeling that there's a silent thief in your facility? Something that's quietly siphoning off profits and making your equipment old before its time? Well, today, we're going undercover. We're going to expose the hidden costs that are almost definitely lurking in your electrical system. And believe me, we're talking about real money and the real-world lifespan of your gear.
So let me just ask you straight up. Is your operation bleeding cash from places you can't even see? Are your most expensive machines, just wearing out way faster than they should? These are super common problems, but the real reason why it's happening? Yeah, that gets overlooked. A lot.
Okay, so let's start by looking at the symptoms. We're going to dive into the common, frustrating, and very, very real costs that businesses like yours are facing, all because their electrical systems are under this constant, invisible strain.
Right, so this breaks down the 4 big killers of electrical efficiency. First up, you've got reactive power penalties. These are literally fines showing up on your utility bill because you're wasting their energy. Then there are transmission line losses. This means you're paying for electricity that just, poof, vanishes into heat before it even does any work. Next, there's premature infrastructure wear. Your expensive transformers, your cables, they're all aging way too fast, which means you're replacing them sooner. And finally, higher installation costs. You're forced to buy bigger, more expensive equipment just to handle an electrical load that isn't even real. These aren't just technical terms, they are direct hits right to your bottom line.
Now, what's really wild is how this problem just cascades through your whole system. It's like a domino effect of damage. For your electric motors, it means they're overheating, their bearings are under stress, they're just on a fast track to failure. For your transformers, the core is heating up, the oil is degrading. Your cables and bus bars are aging faster, and your switchgear, the contacts are literally eroding away. See, it's not one single problem. It's a slow, silent decay of everything from the inside out, and that just creates this endless cycle of surprise maintenance and really expensive downtime.
So, what's the common thread here? What's the link between all these expensive headaches? Well, it turns out we can trace it all back to one single culprit, just lurking in your system. It's time to identify the villain of our story.
And here it is, reactive power. This is the bad guy. It's what causes something called a low power factor, which is basically just a report card for how efficiently you're using electricity. A perfect score is 1.0. A low score means you're wasting energy. Honestly, the best way to think about it is like the foam on a beer. It's in the glass, it's taking up space, and it makes the whole system work harder just to get you the good stuff. But you can't actually drink it. It's useless power that does zero productive work, but it clogs up your electrical pipes and causes all the problems we just talked about.
But here's the good news. For every villain, there's a hero. And for this particular problem, there's a very direct and very effective solution.
And that hero is the capacitor bank. This is the specific, targeted piece of tech that's designed to go to war with reactive power and, win.
So a capacitor bank's job is actually pretty simple and elegant. It basically neutralizes that reactive power right at the source. So instead of making your entire system struggle to carry that useless foam, the capacitor bank provides it locally. What that does is it cleans up your power supply, which frees up your whole system to deliver only the good stuff, the real productive power that actually gets work done.
Okay, so we've met our hero. Now, let's check out the after picture. What are the real, tangible benefits you get when you install a capacitor bank and finally have a healthy electrical system? And the transformation is just, it's night and day. Your power factor gets corrected, bringing you super close to that perfect efficiency score. Those energy losses from heat, drastically reduced. The efficiency of your machines is optimized because they're finally getting clean power. And your voltage becomes stable, which protects all your sensitive electronics. We've literally taken every single problem we talked about and flipped it into a strength.
Okay, if you need one single number to really understand what's at stake here, get this. For every 10 degrees Celsius jump in heat caused by that reactive power, the life of your motor's insulation gets cut in half. 50%. That's not a slow decline, folks. That is a super fast path to total failure. And just think about the cost, not just of the motor, but the lost production while you're down. A capacitor bank prevents that overheating, and it directly preserves the life of your most critical assets. And you have to remember, this isn't about saving just one motor or one transformer. The benefits create this amazing ripple effect of stability and reliability across your entire operation. You stop paying those penalties, you protect all your equipment from damaging voltage spikes, and maybe most importantly, you prevent those insane power outages that can totally cripple production.
So you're probably thinking, okay, this sounds great, but how do I actually get it done? Well, it might sound complicated, but putting the solution in place is actually a really straightforward engineering process with a super clear path forward.
Now, it's not a one-size-fits-all kind of deal. There are three main types to choose from. You've got fixed banks, which are simple, always-on solutions for places with a really steady load, like a pumping station. Then there are self-regulating or automatic banks. These are smarter. They adjust on the fly as your power needs change. And finally, switching banks, which you can turn on and off for specific, heavy-duty jobs. The right choice is just the one that matches how your facility actually uses power. And the whole process really breaks down into 5 clear steps. First, an engineer assesses what your system actually needs. Second, you pick the right capacitor bank based on that data. Third, you install it. Fourth, you test it to make sure everything's working perfectly. And fifth, you just monitor it to make sure you're getting that efficiency. See? It's a well-defined project from start to finish.
All right, let's bring this all home. When you look at the costs, you look at the risks, and then you look at the clear benefits, the conclusion is pretty undeniable.
You know, the source material we use for this says it all perfectly. This is not an optional upgrade. It's not a luxury item. For any modern industrial or commercial operation that wants to boost performance and slash costs, a capacitor bank is, simply put, essential.
So I'll just leave you with this one thought. Think of your electrical system as having a health score. We just walked through all the symptoms of a bad score, and we also went over the exact prescription to fix it. So the only question left is, what's stopping you from improving it? What's stopping you from making your system healthier, more efficient, and way more reliable?